Hello everyone and welcome into yet another live stream. Yeah, as you can see, this is a camera stream. We have a camera. Oh, that's strong. It's coffee strong, not bun. Anyway, so yeah, yeah, we are streaming. Fun. It's kind of upsetting actually because right now it's around 5 a.m. in America, which is rather upsetting because that means most of the crowd that is usually on streams cannot join. That's upsetting because that's kind of the crowd I'm making this for. But I thought I would start 2 hours early, get some work going. Then when they join up, we'll already have something fun to show them. So what will be doing today? Well, first of all, let me just. You hear words, but you forget. Put your fingers receive to it. When the stains, nothing remains. The sound. Okay, that's the. Stipendium songs. Yeah, they will do stuff of stipendium songs, and that's due to the fact that we will be doing some actual fun work, and I am excited for it. Okay, no, I'll be singing then. I don't wanna sing on stream. People will leave then. The fat rat. I'm sorry, but stipendium songs are too good. Wait, why did it start with Afterlife? And there's a button that shows you more, but no. I'd rather start step by step, default. Yeah, I cannot read. I don't want to play so many because the songs are too good. I will just sing on stream. That's terrible. People will leave. Alright. So, first of all, alright, I already pinged. And today. This. There we go. I have no idea where to put this. I mean, it's just like over here in the middle, right? That seems good, yeah. So, I'll put it over here. Yeah, it looks actually pretty not that horrible, hopefully. Pretty horrible. Oh well, that's good enough. So, today we would like to design a circuit. The question is, how would we go about designing the circuit? Well, because obviously we're not going to build it over here. That would be madness. First we have to plan it. Plant the circuit. As you can see, this is already a mess. There's so many stuff you cannot see. You can see now. There's a lot of stuff here, and we would have to organize it better. So yeah, for now oh, by the way, you can see. Oh, that's some very organic race. All right. So, how do we end when? Well. Honestly, it's very tempting for me to design the circuit in Blender. It's very tempting to design the circuit in Blender, but I feel like I shouldn't. I feel like I should not, although it would be easy and convenient. Should I design? I don't think I should I? It feels like a bad idea. Oh well. That is the easiest thing I know. Right, so here's the idea. Here's the basic idea. We will start with the floor like this, and we will design circuit on it. Desktop projects, and over here we had circuit somewhere, right? There's a dream has never died, so come and fly, come and fly, come and fly. I remember when I used to, as a young guy, I used to stream Hypixel with this in the background. It was great. It was sick. Those were the streams. All right. Well, let's call it. Battery charger. Good enough. That's very descriptive. All right. So here's the basic idea. We'll have some sort of source. Actually, maybe not. Actually, you know what? I haven't. No Photoshop or maybe Paint actually, because. Yeah, why paint? Well, it's because we'll have to do some calculations. First of all, the question is, what should I use to power the circuit? USB-C voltage and current output. What is it? Because that will be important. If USB-C will not have a good enough one, then. But we should determine what's a good enough one before we go in, right? before we check. Bicycles. Yep. Alright, so what will be a good voltage and current for this? Well, it would be, we would need to charge a 1.2 volt battery, right? That's the base. Let's use this as a reference point. 1.2 volts. Oh no, we are looking for a current source, not a voltage source. I'm an idiot. So, alright. Previously we used, so what is recommended, by the way, for battery charges? Was it 100 milliamperes? I feel like I keep forgetting that you shouldn't be as precise for these. Yeah. Oh. Ha, that's a lot of amperes. Murica. Yes. Wait, excuse me. Am I not in... Where am I? I'm in Poland! It's scary. I'm terrified of Polish people. Okay, yeah, so these are the yes, pins. These are them pins. If we wanted, we could just... That's actually a very good side. Oh my goodness gracious, that's... I love this. Alright, so... Oh, I really like this graphic. Oh wait. In designing in the USB Type-C and using power delivery for rapid charging, I'm just mostly looking for no current output. That's max current output. That's the same thing. One more row. So what we are looking for is this, yes. That's upsetting because that means there are different options for this, and that's scary. Maximum 100 watts, by the way, on the USB. Okay. USB PD. What now? USB PD 3.0. What and how and what now is this? Shopping, actually. That's a good question. How much does this cost? Do people have these cables? Oh, detection module. AliExpress. Don't be in Polish. That's no. Ouch. You. Don't be. You. Wait, just one thing. Alright. I'm back. EU is in Polish. Decoy detection. What does it mean? I don't understand. Okay, I have to change my place to something different. Let's go to United Kingdom. Alright, we'll confirm. We have to go to UK. You have to know your enemy. Oh, right. Yeah, that's reasonable. I'm looking for a cable. Wait, but... Wait, am I understanding this correctly? And by the way, this... No, this is not what you're looking for. One bit. thing is, what will be the limit for well, because here I need some kind of lower bound for this, right? I need some kind of lower bound for the cable to know what's the lowest amount of amperage I can expect. A voltage, or maybe voltage? Maybe voltage source would be better, right? Maybe? Maybe voltage source would be actually more constant. I suppose, yes. Alright, so what we need to do... this will be actually a bit more of a pickle than I expected, honestly. Because here's the thing. Here's the pickle, right? The batteries require different amount of amperage and different amount of voltage. Voltage is easy because you just input voltage with battery, right? For that we will use digital potentiometers. This simple. Alright, so let's create a kind of crude diagram for this. So here we have our box full of batteries, right? Let's say 4, because why not? 4 batteries. Now, what kind of amperage would we need to charge this box of batteries? Well, any would do, but the higher the better, unless we overcharge. That is true. So we have 4 batteries, all of them add up to 4 times VB, right? And here's the thing, what voltage to use for battery charging? Yeah, but that's car battery charging. In comparison to battery, lead acid. No, it's nickel metal hydride, preferably. By the way, for battery charging equation, if I may, is there? Charging current and time. It's not quite what we are looking for. Is it just the battery voltage that we should use? Yeah, that's obvious. I mean, that's how you calculate time. Just this is amperage per hours divided by amperage leaves you with hour. Yes, that's how that's how units work. The voltage. Oh boy, that sounds like exactly the question I asked. Because of manufacturer specifications. ChatGPT, by the way, is here. What voltage required to charge a battery depending on battery capacity? For example, we could let us cover requires between 12 for. Thank you for not answering my question, just telling me. It is important to use correct voltage. No fucking way. Am I supposed to use just battery voltage? Is that good? Wait, can I ask a next question here? Because that would be... Oh no. Follow-up question would have to be asked over there, which nope. That's a battery. I don't know if we'll be charging those. I don't think so. Two-step constant voltage, if I'm not mistaken, this is a advanced and good technique. At least from what I've read. But to be fair, I can't read, so that might not be true. Battery, yep. Constant voltage to the battery limits the initial charge current according to specified charge and temperature characteristics. Overcharge. Okay, so we cannot go for. battery voltage when it. Okay, so when it flatlines, you just, yeah, I suppose. Taper current. Not recommended. Okay, cool. It's awful. Nickel metal hydrate is preferably. Back one day, I'm pretty certain. Back one day, open left bracket. Yeah, back one day, space left bracket, the outro song. Or outro song, no, outro song without D, I'm pretty certain. Nickel metal hydrate battery. Yeah, I misspelled a couple of stuff there. I know this site. I've been there already. Take control. Crushing over this day. We'll be back one day. Incorrect charger. Yep. Room temperature. Check cell temperature. Should I add, by the way, like temperature? I probably should, right? Add the temperature checks. These shouldn't be hard. Do I have any like temperature detecting stuff? Give me a second. Let me check. Let me actually. That's a good question. Do I have them? Do I or do I not? Well. Well. This. Alright, well. This thing with full of detectors and other fun stuff which can limit the flow of current or enable it, and also capacitors, lot of capacitors. My question being, if I pull out the random thing which kind of looks like a heat detector, not the heat detector, only the thing that changes resistance based on temperature, is it this thing or is it a capacitor? That's a good question. They look very similar. "22 rels." That's what it says. 22 rels. No, nope. HS. REHS. Engineering Historical Society. Nope, I don't think that's what we are looking for. Electronics component. Electronic component. This, yes, that's kind of. Sensors, yes. Oh, it's a sensor. That's good. That's very good. That's hopeful. That may mean it's a thing. List of electronic sensors. Photo detector per sensor motion. Position, no. Photoresistor, yeah. List of electronic resistors. We have therm resistor, obviously. Therm resistor. It looks a bit different. I'm pretty certain I have the deed somewhere, but somewhere is a very vague thing in my case. Electronic components, no, these are only components, and these I'm pretty certain these are capacitors. I mean, we could just check, right, in a very dumb way, which basically means we'll take them two cables. We'll take this resistor out. We will connect this to the plus over here. Diode through the plus, like so. Then connect this to the minus, if I may. I'm using red for the minus because I'm edgy. Yeah, as you can see, it's glowing now. And now if we just put this magical component in between the diode and the plus, actually. then what's gonna happen? Well, a magic trick, that's to be certain. That's something magical. Yeah, it has two ending both the same length, which should cause me to believe that this does not care which way the current is flowing. Diode's off. They don't it don't be doing anything. Now it's dim. And now it just died. And now it's dim. You see it, by the way. It's dim. And it keeps dying. Wait, if we move these cables, like, there we go. Oh, there we go. It's just, you know, you have to, it's like an instrument. You have to move them correctly. So I have no idea what this component is. It's just chilling here. That's what it is. Oops, I broke it. So I do not have any temp resistors. Might need to buy them. Alright, yeah, but the temp resistance detection is very simple. We just need two nodes on the two pins on the Raspberry Pi. So it's simple. Yeah, I do not appear to have anymore. Okay, that's fine then. Give me a second, just let me. Alright, I'm back. Now. So, I suppose we'll get an input circuit. We might need to work with a lot of unknowns here, alright? But here's the basic idea. We will work with a lot of unknowns. Here's the basic idea. We'll have, I should do it in Photoshop probably, right? Yeah, I know we don't see anything, but I'm just learning Photoshop, starting it. That's it. Nothing interesting to see here. New file, let's do it in 4K because we are fancy, and let's save it on my computer, desktop, projects, circuits, here, I'm saving it, circuit, plan, there it is. Alright then, let me just minimize this window. There we go. Alright. So first of all, let's have every single component we might need for this. Well, that's when it comes to the custom in quotation marks, that would be a Raspberry Pi Pico, battery charger, and input. Those are the most important ones, right? Why do I feel so sleepy? It's horrible. I woke up, I had coffee. Fresh air, that's the thing. Fresh air and more light. Those two things always wake me up. I never wanted to sleep. If you know that is from then. Good for you, because it's a good song. Memento Mori. Alright. Let's do it step by step. So we'll have the battery. Place with batteries, right? Oh well, I screwed up then. Whoops, not what I meant to do. Over here. There we go. Let's delete this. Pointless. We'll have our battery place. Then we'll have this. We will have raspberry, and then the input output. So like this. Great. Let's do it then. We'll add a layer. So over here we'll have the base, right? Move all of these into the base. And we'll have batteries. Raspberry. Don't worry, I'll make it prettier. In plus and in minus. Alright. Now, this raspberry. Beautiful. This is beautiful. Alright. Great. Perfect. I mean, come on. Now you can clearly tell I'm a graphic designer. There we go. We have the raspberry, and then we'll also have the battery. The battery. The raspberry and the battery. Here are the batteries to charge. Match layers. I said. Grand. Now, what are our unknowns? Well, our unknowns are rather simple. How many batteries there are on the okay, so first of all, the battery case we'll have to design it separately, because I'd really love to design one where basically you don't need to put in all the batteries. It's not hard, obviously. It's obviously not hard, but to be fair, I am dumb, and you know, hardness is relative, so for me it might be quite difficult. Now, the thing that we do not know is the current source, because there will be a source of current, most important thing, right? How many amperes we'll get there. So, input amperes. Let me just... Full of pain. Why don't you sing along, my friends? Dusty flame. Forever young, never strong, never late. Memories like the soldier, and they don't fade away. Alright, I. So we have the... There we go, shadow will give us some of that sweet, sweet visibility. So we have over here I. Yeah, later could be convenient in this scenario. I B I input. This is our first thing. I input. Yep. So we have some sort of current going in. Now we would love to pass this current into the battery to charge it. The thing is, we cannot just, you know, push it in there. We will need to have something in the way. Those two things in the way will be two potentiometers. Why two of them? Well, it's because this. I remember I had the reason, which I wanted two digital potentiometers, but I genuinely cannot remember. Well, let's just think. What exactly do we need this to do? Well, what do we need this to do? Well. Now it's really easy to add additional stuff to the circuit or anything actually in existence, but it's really hard to create one from the scratch, right? So we need this to charge the batteries whilst the Raspberry Pi controls the current and the voltage of this entire thing, which means we would need, first of all, use the potentiometer first one as a voltage divider to how much current would go for the batteries and how much current would just straight up, go into the void. Alright. So is this, right? Digital. Actually, no, it doesn't matter. We'll create our own symbols. It's for ourselves anyway. So this cancel. Nope. We will need this over here, like this. Components. I have one friend. They always hate when I create my own standards for stuff. But it's for myself. I'm making these standards only for myself. I know that there are better standards if anyone else wants to use them. So it shouldn't do any harm creating my own. Okay, so we have this digital potentiometer, and when it comes to potentiometers, then these work like voltage dividers, right? Which means they work exactly how? Well, there's a voltage divider. Hence 3 pins in the potentiometer. And no one, we'll use a digital one, which means we'll have like 8. It's rather funky, but anyway, well, over here. Wait, I forgot I must kill this thing, so let me just move it like so. There we go. Damn it, I killed the diode! Maybe I didn't. I just... Oh, there we go. Now it started glowing. Alright, cool. So voltage divider, if this is our input, this is our output, right? Then over here we have resistance 1, resistance 2, and R2 divided by R1 plus R2, that's the equation if I'm not mistaken, for how much is going out this way, right? So if this is B, then voltage B would be equal to this. Let's double check. Voltage divider. Yeah. Is this something like current divider? Oh, it's the same thing. Okay, great. Yeah, so... Yeah, current divider rule, wait. Must be divided among resistors parallel. Use current divider... Oh, so it divides like this. Okay, so this is actually what we care about. Over here, them circles. Like this. Resistor, resistor. Then this would be R1, this would be R2, and I1, I2, and I1 is equal to resistance second divided by resistance of first plus resistance of second, IS. This is IS. So here's the thing. This works in parallel well. If we have our voltage divider, though, it's different. That's why we need two potentiometers. Right? I think. That's what we are going for. This will be our input current, which we'll get from the source, because we'll use a current source, hopefully. Get a current source from the outlet, if I may. Power outlet will be taken as a current source, yes. Between them is the outlet pins. Okay, so we are working with a voltage source actually. Hiding in the blue. That's hiding in the blue. Yes! Oh yeah, I'm good at this. Alright. How to use USB? Well, I feel like we should charge it from the outlet. Just okay, cool. Then another component to add. Okay. Transforming outlet AC to 30 volt to DC. To 5 volt. Well, 5 volt might be a bit of an overkill. Power supply unit, yeah, we might need to buy some. AC to DC converter. Shopping. This, yes. $71, that's not as bad as it could be. But I need a step down from Ooh, that's pricey, but good, if that's what we are looking for. Because this would step down AC to 20 volt to DC 12 volt. Hopefully eBay. Oh my goodness, that's pricey. Can I get like maximum 3 pounds? Maximum 4 pounds, right? Let's do it. Maximum 4 pounds, that's all I'm willing. And maybe not from AliExpress, because I might need it a bit faster delivered. Wait. And what now? It's from AliExpress, so that's suboptimal because delivery will take so long. Is there anything not from AliExpress? I'd rather not get it from AliExpress because delivery will take me 7 years. Okay, but these things cost around £2, £3, maybe 4. Understood. This though is interesting because adapter, converter, because here's the thing. Oh, I really like that idea. Uh, 230, alright, so AC 230 volt to 12 volt converter with plug. Just because with 12 volts, them wrong plugs European. European standard. I'm not saying it's better, but I'm saying it's better. This is kind of what I'm going for. All of these plugs are so expensive. To be fair, they are converting. They are so expensive though. Is there anything like up to £10? Please, bicycles if I may. There we go. Oh, these are... Damn it! I will need a plug then, right? If I'm making this converter, I will need a plug. So if plugs are this expensive... Oh, that looks good, but this is some sort of... This is not in bulk, is it? Like if I was trying to in stock 79, yeah, it's not in bulk. This is good, it's good. How about like up to £5? Because £5 for this, that would be decent. This is cheap, but it's not quite what I'm looking for. I'm looking for a... That is wrong plug, but right idea. This is right plug, right idea. £4, that's pretty decent. 60, more than 10 available. That's eBay, by the way. That's the right price, right idea. Except this seems like a scam, honestly. 90,000, love it. Oh, I love it. EU plug, DC, yeah, graphic design is sick. I dig it already. Shipping costs more than the product itself. To be fair, I might have some of these. Wait, what am I doing? I'm trying to get it as a prototype. No, wait, I'm trying to get it as a prototype. Why did no one in chat stop me? I'm such an idiot. Wait. If I'm trying to get it as a prototype, then I have this. This is a charger for. This is a charger for walkie-talkies, which I had, and it's broken, as you can see. It's screwed up, and basically it has a cable which goes right into the wall, but the walkie-talkies are clearly being charged with DC current, which basically means that if I were to break it off completely, I would get a pretty decent, and by pretty decent I mean hopefully right, but recharging is only applicable to speed of charge. Shut off power whilst charging. I assume that means shut off power of the, you know, okay, right, let me just... There is no way to open it, which means I might need to just, you know like, just crack it. It's always a delicate process when it comes to cracking stuff. It's already a bit. I don't want to, destroy the electronics inside, so I'll need to be very delicate. Okay, probably I shouldn't be doing the gun. I should probably get a hammer or something. All right, bit of it. But this might actually work. This might actually kind of work. Oh, I should probably also check if I have anything else. Well, I have some coin chargers over here. No, it's not good. Do I have anything? Do I have any charger for something broken, which I could use? Well, I do have. No. I have so many old stuff. Why can I not get a single quick charger? You see, that's the issue. That's the problem with society. People throw away stuff which people like me could use. Like there are so many broken chargers. I would adopt them all right now because all I need is one correct, simple, nice AC alternating current to direct current charger, and that's it. We would be on our sweet way home then. I don't want to break the. I really don't want to break the walkie-talkie charger, but if it's the only option. How hard would it be to build an AC to DC? So wait, AC to DC converter circuit. So, I assume it wouldn't be easy, right? This and this are the two issues. I suppose I could. Wait, can I not do it if I dismantle this relay module? Can I not? Kind of, maybe. Wait, these are diodes. These are just 4 diodes. This is a capacitor. This is an issue, but doesn't need a relay module. I mean, this part is inside the relay module, is what I mean. Oh, you don't see, by the way. I'm talking about. This part is inside the relay module. Taking it out, it would be a mess. So, 3 steps. Doable. I have no idea what it is. Yes, doable. Yep. TR1, 2, and 1, and 4001. Electrical, yes. That's the voltage regulator. What? How and what now? It's an inertial meter, there's nothing wrong with that. Alright, so yeah, it wouldn't be easy to build one, obviously. But I really don't want to dismantle any of the existing chargers I have. Them all some good ones. Really. Here's the thing, if we could make, because problematic, that's what I'm saying. Wait, but this one already changes it when it goes over there, which means we could just cut that cable and we would get the things we require. And what's the message now? Right. Okay, that message actually is a bit important. Give me a second. Right. So. Two amps with 12 volts. That's decent. 2 amps is a lot. For 12 volts especially. That gives us 24 watts, which should be more than enough. It's from AliExpress. 74. That's cheap. Oh, I can use this coupon to get -1 pound. 36 days. Estimated delivery. There's a way, obviously, for me to buy one, which would be more expensive, but I could also hit the shop. The shop is open, like the hardware shop. You know, like from the Weird Al song, hardware shop. I could just go and hit. It's tempting. This is good. This is a really good one. It's exactly what I'm looking for. Should I go to the hardware store? Ay. 2,809 pieces available. That's so convenient. I need half of that. I really need 1/3 of that. That's such a good one. Should I? But fudge sticks. It's perfect. This is perfect. This is perfect what I need. I would just cut the cable over here, or maybe over here, a bit more professional. Input it into the thing. And then part of it would go to the Raspberry. A very tiny part of it. The most part would go. We would basically just do a current divider. So that tiniest little part would go to the Raspberry, and the most part would go for the charger. That could charge stuff. It's a really good one. Should I go to the hardware store? Okay, let's imagine DC 12 volts 2 amps, right? Let's say that that's what we get. So as an input, if we get 12 volts 2 amps, that's our input. E is equal, I is equal. It's a decent, yeah, this is decent, I would say. Then if we are trying to charge these batteries, we would probably like to charge them with, well, actually that's a lot. Now I'm thinking about that. It is a lot. And we'd preferably like to reduce voltage significantly. I really need a Watson for these streams, Watson who would just asking me questions, because then I would think better. I need a Watson. Anyone out there available with my Watson? Let's say that for input, right, and output, all we would need is 1.2 volts. So we wouldn't use this one, only would use VB as our voltage. Our current then should be divided by, wait, yeah, this seems a point is that my American crowd with Elliot and Crumphy burying exams and my American crowd out there sleeping on the other side of the globe. Oh yeah, we can just imagine it as a parallel circuit of single battery charges. Oh, that's smart. Oh my goodness, that is, well, maybe not smart, but from where I'm sending it's smart, like this. And then we can like, yeah. Oh, that is so simple actually, right now. Because you see, right now, all we have to do is just calculate the voltage and, well, voltage would be the same for all of them, right? We already established that now. So just calculate for the voltage, and current also the same for all of them, but so we have divided evenly, not that hard, but we also will have to divide it into 4s with a current divider. Yeah, that's so simple. Alright. I really want to go to the hardware store and buy this thing now. It's the only thing I'm missing. Right, we'll leave that for the American crowd. So for now, that'll be it. Thank you so much for watching, and have a great day. Bye!